In today's video, we learn about determining a differential equation from its general solution. Determining a differential equation from its general solution is the process of eliminating the arbitrary constants appearing in the solution to obtain a differential equation satisfied by the family of curves. So all that we have to do is to eliminate the constants in the given general solution. So here are the solution procedures. The first step is to differentiate the given differential equation as many times as the number of arbitrary constants in the given general solution. Second step is to form a system of equations involving the function and its derivative. The third step is to eliminate the arbitrary constants from the system. So after we are done with step 1 and step 3, our final equation will be the required differential equation. Let's start with our first example. So in example 1, we have to find the differential equation whose general solution is y is equal to c1 e exponent minus 2x plus c2 e exponent 3x. So here we have two constants, that's c1 and c2. So we have to differentiate this equation twice, then we solve for the system. Then we are going to get our required differential equation. So now let's differentiate y. So y prime will be giving us, so this guy is exponential, right? So we just have to differentiate the exponent, then we multiply. And so we are going to have, when you differentiate minus 2x, you are going to have minus 2. So that will be minus 2 c1e minus 2x. Then when you differentiate 3x, you're going to get 3. So that will be 3 times c2e 3x. So since we have two arbitrary constants, we have to differentiate it one more time. So y double prime will be giving us, so here we use the same idea, you differentiate the exponent. So when you differentiate minus 2x, you're going to have minus 2. So minus 2 times this minus 2, that's going to give you 4. Then we do same for the last term, we differentiate 3x, that's going to be 3. So 3 times 3, which is 9. And so our result is going to be 4 c1e minus 2x plus 9 c2e 3x. So let's call this equation 1, equation 2, and equation 3. Let's focus on equation 1 and equation 2, right? So suppose we want to eliminate c1 from both equations, that's equation 1 and equation 2. We have to multiply equation 1 by 2, so that we are going to have 2y, then 2c1e minus 2, then 2c2e 3x. Then in that case, when we add equation 1 to equation 2, these two guys will cancel out, right? So now let's multiply equation 1 by 2. And so equation 1 will be giving us 2y is equal to 2c1 e minus 2x plus 2c2 e 3x. So let's call this guy equation 4. Adding equation 2 to equation 4, we are going to have y prime plus 2y is equal to c2 e 3x. So let's call this guy, say, equation 6. So we now focus on our systems of equation, that's equation 1 to equation 3. So at first we were dealing with equation 1 and equation 2. So here let's pick equation 2 and equation 3 to eliminate c1. So when we multiply equation 2 by 2, you will see that this guy will be minus 4. So when we add minus 4c1e minus 2x to 4c1e minus 2x, this part will go to 0, right? In that case, we can have an expression for c2. So we are going to multiply equation 2 by 2, and then we add it to equation 3. Now let's multiply equation 2 by 2. So that's going to give us 2y prime is equal to minus 4c1 e minus 2x plus 6c2 e 3x. So let's call this guy equation 7. We will now add equation 3 to equation 7 to eliminate c1. So we are going to have y double prime plus 2y prime is equal to, so here this plus that will go to 0. And so we are going to have 15c2 e3x. Then we call this guy equation 8. When we added equation 2 to equation 4, we got equation 6, right? Now, how do we eliminate C2? So from equation 8, we can see that we have 15C2E3x, right? And we can write 15 as multiples of 3. And so we can rewrite equation 8 as 3 times 5 C2E3x. So this is equation 8. Now let's look at something here. We have 5C2E3x and we also have 5C2E3x. So this guy is equal to the left hand side of equation 6. So we can write y prime 2y in place of 5C2E3x. So equation 8 will be giving us y double prime plus 2y prime is equal to 3 times, and now 5C2E3x is equal to y prime 2y. So that will be y prime plus 2y. Now let's simplify further. So we are going to have y double prime plus 2y prime is equal to 3y prime plus 6y. Simplifying further, we are going to have y double prime plus 2y prime minus 3y prime minus 6y is equal to 0. We are going to have y double prime minus y prime minus 6y is equal to 0. Hence, the required differential equation is given below. Now let's try question 2. Question 2 says that eliminate beta and alpha from the relation x is equal to beta cosine of omega t plus alpha, in which omega is a parameter not to be eliminated. So here our focus should be on beta and alpha. So we have to eliminate these two guys. So here we have two constants, that's beta and alpha. So we have to differentiate this guy twice. We can approach this question in two ways. The first approach is to expand cosine of omega t plus alpha. So we know how to expand cosine of alpha plus beta, so we just use the same idea. Or we can differentiate this guy straight away using the chain rule. So now let's use the chain rule to differentiate. So x prime will be giving us, so here we are differentiating with respect to t. So we apply the chain rule. We differentiate what's inside this function. So when you differentiate omega t plus alpha, we are going to have omega, since alpha is a constant, it will go to 0. So that will be omega. Then we now differentiate this entire function. So when you differentiate cosine, you are going to have minus sine. So that will be minus beta sine of omega t plus alpha. Then we now differentiate it one more time. That's x double prime will be giving us, so we apply the chain rule again. So you differentiate what's inside the trig function. So you're going to have omega. So here will be minus omega squared. So minus omega squared. Then when you differentiate sine, you get cosine. So that will be beta cosine of omega t plus alpha. So now we have to eliminate the constants from this system. So let's call this equation 1, equation 2, and equation 3. So from equation 3, we can see that we have beta cosine of omega t plus alpha, which is the same as equation 1, that's beta cosine of omega t plus alpha, and that's equal to x. So we can replace this with x. So equation 3 will be giving us x double prime is equal to minus omega squared. Now what is left is giving us x from equation 1. So here will be x. We've been able to eliminate the constants beta and alpha. And so our required differential equation is giving us x double prime plus omega squared x is equal to 0. Our third question is giving us determine the differential equation whose general solution is y is equal to c1 e exponent x plus c2 e exponent minus x plus 4x. So here we have two constants, that's c1 and c2, so we have to differentiate this guy twice. The y prime will be giving us x, we're going to have 1. So 1 times c1 is just c1. So c1 ex. Then we differentiate minus x, that's going to be minus 1. So that will be minus c2 e minus x. Plus, when we differentiate 4x, we are going to have 4. Then we differentiate it one more time since we have two constants. So y prime prime will be giving us, when you differentiate x, you have 1. So 1 times c1 is just c1 ex. When you differentiate minus x, you get minus 1. Minus 1 times minus c2 is plus c2. So that will be c2 e minus x. Then 4 will go to 0. So we have equation 1, equation 2, and equation 3. So as we did in the first example, we just have to solve this system, right? So now let's solve this system. So now let's focus on equation 1 and equation 2. So from equation 1 and equation 2, we can add equation 1 and equation 2 to eliminate c2. Since this is plus and this is minus, when we add equation 1 and equation 2, we are going to get rid of c2. Adding equation 1 to equation 2, we are going to have y plus y prime is equal to 2c1 ex. Then this guy and this guy will go to 0. So we are going to add this to that. So that will be plus 4x plus 4. So let's call this guy equation 4. Let's now focus on equation 2 and equation 3. So we can eliminate c2 from equation 2 and equation 3. That's when we add equation 2 to equation 3. We are going to get rid of c2. Adding equation 2 to equation 3, we are going to have y double prime plus y prime is equal to 2c1 ex, then plus 4. So let's call this guy, say, equation 5. So now we focus on equation 4 and equation 5. How do we eliminate c1? Let's focus on the right hand side of equation 5. We have it to be 2c1 ex plus 4, of which we have the same expression on the right hand side of equation 4. That's 2c1 ex plus 4. So we can move this guy to the left hand side of equation 4, right? So we can rewrite equation 4 as y plus y prime minus 4x is equal to 2c1 ex plus 4. So let's call this guy equation 4 star. That's, we just rewrote equation 4, right? So we have the right hand side of equation 5 and equation 4 star to be the same, right? So we can write this in place of that. So that's, we are going to have y plus y prime minus 4x is equal to, and now this guy is just the same as this guy, right? Because this is equal to that. Is equal to y double prime plus y prime. Now let's simplify this guy. So let's move everything to the right hand side. So we're going to have y double prime plus y prime minus y prime plus 4x is equal to 0. So that's y double prime minus y plus 4x is equal to 0. With our last example, we have to eliminate the constant c from x minus c squared plus y squared is equal to c squared. So let's expand this guy, right? So expanding this guy, we are going to have x squared minus 2xc plus c squared plus y squared is equal to c squared. So that's x squared minus 2xc plus y squared is equal to c squared minus c squared. So the right hand side will go to 0. So we are going to have x squared minus 2xc plus y squared is equal to 0. Now let's differentiate this guy. So here we have to use implicit differentiation because this function is not explicitly defined. So differentiating x squared, we are going to have 2x. Then differentiating minus 2xc, we are going to have minus 2c. Then differentiating y squared implicitly, we are going to have plus 2y y prime is equal to 0. Dividing through by 2, we are going to have x minus c plus y prime is equal to 0. Now let's find c. So c will be giving us x plus y prime is equal to c. So let's call this equation C star. Now we go back to our given general solution, which is defined by equation A. So we now have to substitute star in A. So we write x plus y prime in place of c in this expression, right? So we are going to have x minus c, but c is giving us x plus y prime, then all squared plus y squared is equal to c squared, which is x plus y prime all squared. Now let's simplify this guy. So we are going to have x minus y prime all squared plus y squared is equal to x plus y prime all squared. So this will cancel out this. So we are going to have minus y prime all squared plus y squared is equal to x plus y prime all squared. So now let's simplify this. So we are going to have y prime all squared, because when you square minus 1, you're going to have 1 plus y squared is equal to, now let's expand the right hand side. That's going to give us x squared plus 2x y prime plus y prime all squared. So here we just have to simplify this, then we can get our differential equation. Now let's move everything to the right hand side. So we are going to have x squared plus 2x y prime plus y prime all squared minus y prime squared minus y squared. And so this guy will cancel out this. Thus we are going to have x squared plus 2x y prime minus y squared is equal to 0. Hence the differential equation is giving us 2xy y prime plus x squared minus y squared is equal to 0.